So this is what we've been doing for our derivative. The limit as h approaches 0, f of a plus h minus f of a over h. We are going to change our notation just a tad, and we are going to, instead of using a's, the book switches and starts using x as the variable there. We used a's because on the previous section we were almost always then just immediately plugging something in. But the notation is kind of, when you're going to plug in something, they would use a's a lot of times, but if you were just coming up with the equation, most of the time it's left in terms of x. So in terms of our calculation, it's no different. We're just going to start using x's in place of that a value. We know that the derivative in terms of a graph, it's talking about the slope of the tangent line. So I want to take a graph and see if we can draw the derivative from this graph. Okay. In this, we have to look for easy things to help us out. If I wanted to draw the derivative, I would have to come through and essentially, if I wanted to be exact, I'd have to draw the tangent line everywhere along this curve. And that would then, if I found the slopes of all those lines, that would be the values of my derivative. But we're doing a rough sketch. We don't need to be that precise. Are there any places where you would know for sure what the slope of the tangent line was? Zeros. Where do you have zeros at? If you think about these maximum and minimum, if I drew the tangent line there, it would just be a horizontal line, wouldn't it? The slope of a horizontal line is 0. So if I have a function anywhere where it has a maximum or minimum, it would have a horizontal tangent line, so the derivative will be 0 there. So I know my derivative is 0 3 times. Okay, let's just be very generic from here. If on this section of the graph, anywhere I would draw a tangent line, what would the slopes of those lines have in common? They're all negative. The graph is decreasing, all those slopes would be negative. So that means my derivative has to be negative until I get to this point. What do these have in common? Those are positive, so my derivative would have to be positive there. Now, if I'm not going to be any more precise than that, I know this section is negative, this has to be positive, but I have to come back and hit this point, so it would have to turn around and come back. Okay, what's this section of the graph? This is decreasing, so all my derivatives would be negatives again. And then after that, my function is increasing, so my derivatives are positive. Now, this graph is by no means perfect. I have the correct positives or negatives, and I have the correct zeros. As far as the actual values, the steepness of my graph, those I probably have some errors in. And we will get better at this. We're going to continue in the coming sections to talk about characteristics of these graphs, so our graphs will get more and more accurate as we go along. But right now, we're just looking at the big picture. So, what we need to know here is that anytime the tangent lines are horizontal, the derivative will be 0. Anytime the function is increasing, the derivative is, and if the function is decreasing, derivative is negative. Those are the big pieces we need to take away from that. So let's look at this example. It's very similar to what you were doing on last night's homework. If the function is x cubed minus x, I want to find a formula for f prime of x. So this, notice it's f prime of x, not a, so I have to keep it in terms of x, not a. So what we're going to do is the limit as h approaches 0, f of x plus h minus f of x all over h. Okay, so f of x plus h, if I put x plus h in here, we get x plus h cubed minus x plus h minus f of x would just be x cubed minus x all over h. Okay, can I show you guys a shortcut for cubing? I don't know if it will help you. Some people love it and some people hate it. Have you ever seen this triangle? Okay, so basically it starts out, it always has ones on the ends. To get the numbers in the middle, you add. So like 1 plus 1 is 2. So the next row, it starts out with a 1. 1 plus 2 is 3. 2 plus 1 is 3. And then it ends with a 1. The next row starts with a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And this is a 1. Okay, do you guys just see how I'm getting the rows in this triangle to begin with? This can be used for multiplying out. This first row is like when your exponent is 0. I think 0 powers 1. This is when your exponent is 1, 2, 3, and 4. What these numbers do is tell you coefficients. So for instance, if I had x plus h to the first, this tells me my coefficients are 1 and 1. It's 1x plus 1h. Okay. If I have x plus h squared, so you have to start out with this first number squared. So it's like 2x's, 1x, and no x. Your h's will go the opposite. So no h's, 1h, and 2h's. So if you square this, you get x squared plus 2xh plus h squared. If I give you x plus h cubed, so these are your coefficients, so your powers of x go down, that'd be 0. Your powers of h increase, so it's like 0, 1, 2, 3. So it's 1x cubed plus 3x squared h plus 3xh squared plus h cubed. If I want to do x plus h to the fourth, so your powers of x go down, so x to the fourth, x cubed, x squared, x. Powers of h increase, so there's no h, 1h, 2h, 3h, 4h. So you get x to the 4th plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the 4th. That's why on that homework problem that I worked out and had the a plus h cubed, I was able to just write out what it would be. That's how I knew what my coefficients would be. So you certainly don't have to do this. You can write out x plus h 3 times and FOIL it out. Some people this clicks for and some it doesn't. So if you understand where I'm getting this can be a big time saver. If you don't, it's not a big deal because we can certainly FOIL like we've been doing in the past. out with an x plus h cubed. So if I use that trick I just showed you, it would be x cubed plus 3x squared h plus 3xh squared plus h cubed minus x plus h. I'm just going to distribute that negative, so minus x minus h. I also have to distribute this negative, so minus x cubed minus x all over h. Alright, so then if we start simplifying, sorry, this is a plus x at the end, isn't it? If I distribute that negative. Okay, so then I see my x's drop, my x cubes drop. Everything that's left has an h in it, so we could go ahead and drop an h out. So that would leave us with 3x squared plus 3xh plus h squared minus 1. Then, as h goes to 0, you just get 3x squared minus 1. Questions there? That was part A. Part B just asked you to compare the graphs. Let's just let's use our graphing calculator here, even though I know we wouldn't do that on test. I just want you to see those connections. So I want you to graph the original, the x cubed minus x, and the new one, the 3x squared minus 1. If you compare those graphs, you look at the original. Something like this, and then you see the derivative looks like this. So they do kind of match up. This was increasing, so the derivative was positive, it had a maximum, so the derivative was 0. Decreasing, so derivative negative. Increasing, so derivative positive. We can see those patterns. Any questions there? Let's keep practicing these derivatives. So the derivative, f prime of x, is the limit, as h approaches 0, f of x plus h, so the square root of x plus h, minus f of x, so the square root of x, all over h. Can we just plug in our 0 at the beginning here? No. So how am I going to work this problem? What's my strategy? Yep. So I'm going to multiply by radical x plus h plus radical x on top and bottom. give me an x plus h minus x over h times the radical x plus h plus radical x. And then what happens? So then we have 1 over radical x plus h plus radical x. So now if you plug in your 0, we get 1 over 2 radical x. Which we know we really shouldn't leave a radical on the bottom, but we're kind of getting to the point where we are going to start leaving it because eventually we are going to be finding like second derivatives and third derivatives. And what happens is if you rationalize this along the way, those later derivatives become a lot harder to calculate. So we want to keep our answer as concise as possible. So I won't take off for leaving your radical on the bottom. I also asked for the domain of f. Just as a review, do you know how to find the domain of a radical? Yeah. Thing underneath is greater than or equal to 0, so that's just x, so it would be 0 to infinity. Just kind of a bonus question there. The next slide I showed you the graphs of these things. I wanted to make sure you saw the relationship here. This first one is our square root graph, and this is my derivative. Now what you see, does this original graph ever have a horizontal tangent line? No, so the derivative never touches 0. This graph is always increasing, so the derivative is always positive. If you're looking at this portion of the graph, you notice how it's a lot steeper? That means your slopes are bigger. So that's why over here, you notice the closer we got to 0, the steeper those values became. So that's why we have like a vertical asymptote on our derivative. The closer we get to 0, the higher my derivatives are, because it was steeper. As I went on, this graph is flattening out. So my derivatives are getting closer to 0. So in terms of the graph of the derivative, that gave us essentially a horizontal asymptote. The derivative is getting closer to 0 as time goes on. So that steepness of the graph tells a lot about the derivative. The steeper the graph, the higher the derivative will be. As the graph flattens out, the derivative is going to be getting closer to 0. All right. Questions there? Why don't you guys take a few minutes and see how far you can get on this one before you go too far with this. If we're looking at this, f prime of x, so you have to do limits h approaches 0, f of x plus h, so you're replacing those x's with x plus h, minus f of x all over h. So if you wanted, you could go ahead and distribute that negative. It's up to you. What did you do to clean this up? Right. So take top and bottom times both the 2 plus x plus h and the 2 plus x. So if we do that, then on the first, the 2 plus x plus h cancels, so you have 1 minus x minus h times 2 plus x. Keep saying one variable and writing it out. Minus, this one, the 2 plus x cancels, so you have 1 minus x times 2 plus x plus h all over h times the 2 plus x times the 2 plus x plus h. we need to clean this up a lot. So can I go ahead and just distribute my negative? Start canceling as I simplify. So the 2's drop, x's drop, 2x drops, x squared drops, and my xh drops. So I am left with a negative 2h minus h, so negative 3h over h times 2 plus x times 2 plus x plus h. So my h's cancel, and now you can plug in 0, so you get negative 3 over 2 plus x times 2 plus x, or negative 3 over 2 plus x squared. And that is our final derivative. The piece that we're going to look at tomorrow are some of the different notations we might see. We are used to saying f prime of x if our original equation is f of x. If our original equation is y, we could call that y prime. We're also going to see any number of these other things show up. The dy dx, that means the derivative of y in terms of x. Df dx, the derivative of the function f in terms of x. The d over dx of f of x is just saying the derivative of f of x. Sometimes you might see a capital D for derivative of f of x, or d sub x of f of x. All of these mean the same thing. All of those are just telling you to find the derivative. So I just want you to be familiar with them. Typically, I'm going to use these three right here, so those will be the most common, but you could see any of them show up, and all of them are just asking us to do what we have been doing. The other thing that we're going to see is something like this. We had some on the homework where it asked you to find the derivative and then give the slope of the tangent line at a particular point. This is a concise way of doing that. So it might say dy dx, a vertical bar, and then x equals a number. That means tell me the derivative when x is this value. So in those cases, you would be plugging a number in for your x and getting an actual number answer instead of an equation. So we will be seeing all of these different notations showing up. I think that's where I want to stop today. But actually, let's flip to the very back. I put some extra examples on here, and I want to look at this problem number 2 on the back. What this is asking you to do is estimate values from a graph. So on the homework, I may give you one of these. You're not going to be real accurate with it, but we can be in the ballpark. When it says f prime of 0, that's like saying what's the derivative at 0. Now derivative is slope of a tangent line, right? So what we would have to do is actually draw a tangent line here and estimate its slope. So you might grab a sheet of paper or something. You're going to try to draw the tangent line at 0. And then I'm going to see if I can maybe estimate the slope of this line. Kind of difficult to do, but we can maybe get close. Let's see. So maybe this would go up to and over 1/5 maybe, I think. So if I were going to estimate that, I'm drawing a line, I'm approximating the slope, so rise over run. So I was just kind of approximating if I went up here, maybe a 2 rise to over 1/5, and what does that give me? 10. Now, does this mean we're all going to get the same answer if we do these? No, but we can be in the same ballpark. That's all I'm looking for here. So f prime of 1, this one we should all get. What is f prime of 1? F prime of 2, at the very least, what kind of number is this one going to be? Negative. So if you kind of try to draw it in and estimate your slope, and again, I know that's hard, maybe go down 3/2 over 1. So maybe a -3 over 2. Does that look reasonable? F prime of 3, so if you're attempting to draw a tangent line there, so maybe go down 1 over 3/4. What does that give me? -1 over 0.75 is. Okay, f prime of 4. So maybe down 1/3 over 3/4. Down 1/3 over 3/4, is that close enough? What does that give you? F prime of 5. That's the one I did, wasn't it? I drew my line at 5, not 4. Okay, I'm running short on time. Do you guys know how I'm getting these? Estimating. If I don't finish this, can I go ahead and stop right now? Because I want to give you a couple things. Okay.